Now we're going to talk about relative motion. Let's say we're swimming and we have velocity, certain velocity, and this is Vs as a swimmer. And let's say we're swimming with the current. So relative to the ground or relative to Earth, what would happen is our resultant velocity would be the addition of those two. So our motion would be like this. Our total velocity would be the adding up the velocity of the swimmer plus the velocity of the water. Now let's take a look at a situation. Let's say we're going upstream. So we would have the velocity of water, velocity of the swimmer. We would still do vector addition, tail to tip. We place the tip or the tail of the vector of the water on the tip of the velocity vector of the swimmer, and the resultant would be this. And so we would have a resultant velocity slower than the our actually swimming velocity. Now let's say we were swimming across stream. Now we would still do vector addition where we would place the tail on the tip and then draw the resultant vector. So we would have a certain angle at this. This would be like trying to swim across a river. So let's say we have this situation here where we're trying to swim straight across, and we want to find out, well, in part A, we're paddling east, and then we want to find our velocity relative to the shore. So let's say we're paddling, and we're cable paddling 5, and it's flowing east, so our resultant would be 9. And then in part B, we're paddling, and our velocity of the river is still to the east, but we're going 5 to the west, so the resultant would be 1 to the west. And then if we wanted to try to swim straight across, what would our velocity be? So in this case, what we would have to do is set up the we're pointing straight across. The river is actually going to to the right, and so our resultant would be the Pythagorean theorem, and then we would have an angle relative to the shore. And our resultant would be 6.4 miles per hour, 38.66 east of north, if we set up the coordinate axis. So for this one, we're flying a plane with an airspeed of 400 miles per hour. The wind is 80 miles per hour to the west. What must your heading be to fly due north? So this is a little bit trickier because in this case we're actually trying to counteract the wind. So if we had our situation here where, let's say, let's say we're actually just pointed north, and the wind was coming from this direction, what's going to happen? Our airplane's going to shift off this way, right? So when we set this up, we actually have to point our airplane this way. We have to point our airplane to the left so that our resultant is actually north. And so this is, the 400 out here. The wind is 80 miles per hour, and so the resultant is actually the vertical one here. And so the angle we would need to fly is 11.54 degrees west of north. And this is what we would actually do in flight planning. Okay, so let's take a look at a motion scenario where we're accelerating. Well, actually, no, in this case, we're going at a constant speed at a certain direction. We want to find out how far we've gone in the west and how far we've gone in the south. So go ahead and draw the coordinate axis. I'm going to have you try this and see if you can figure out how far west and how far south. And then you can check your answer. So go ahead and pause the clip, and then we can go from there. Okay. So 5 miles, or meters per second rather, we would find out what our velocity is in the x, and then find our velocity in the y. That's one way to do it. And you could have figured out how far at that 40 degrees south of west and then broken it up. That's possible too, to find the length. Then we can just do, for our x problem, we have our time, we have our x velocity, so we would go 574.5 west. And then in the y, we would go 482.09 meters south. Okay, now we'll take a look at a roller coaster design scenario. Let's say the roller coaster is going down a 20% or 20-degree incline with the acceleration of 5 meters per second squared. How far horizontally has the coaster traveled in 10 seconds? How far vertically has the coaster traveled? So it's going to be important to break this up into what's going on in the x direction, what's going on in the y direction. So if we break up our acceleration, what's accelerating in the x and what's accelerating in the y, we can use trig to determine what's going on in the x here. So the x acceleration is 4.7, and then we can use one of our kinematic equations to figure out how far, delta x. So go ahead and pause the clip and see if you can figure out in the y direction how far the coaster has traveled. Okay, so the acceleration in the y is 1.71. Therefore, a displacement of 85.51 south for this. Okay, now in this one, this is an acceleration problem that we're going to need to look at in the x and y as well. So we have a particle that's going through the origin with a speed of 6.2 meters per second in the positive y, and then the particle accelerates in the negative x direction at 4.4 meters per second squared. And so we're going to take a look at the positions in the x and y. And so in this one, similar to what we did before, we're going to have to look at what's going on in the x separate from what's going on in the y. And then we can figure out the positions. So when we draw this out, we can see that in the y, there's no acceleration. So we just use velocities, the displacement over time. We can figure out our displacement. And then for the x problem, we do have an acceleration, and then we can figure out where the location is for that. And in this case, negative 55 meters. Looking at the constant acceleration equation there. Okay, so I'm going to have you try this one. And what you're going to want to find now is what are the x and y components of velocity. So what's the velocity doing in the x, and what's the velocity doing in the y for this situation. So go ahead and pause and see if you can determine that, and you can check your answer. Okay, so we can use our constant acceleration equations for our x situation because we do have acceleration. So the final velocity would be negative 22 meters per second. But for our y problem, there's no acceleration in the y, so that velocity stays the same. Okay, so in this case, we have a wind that's going 15 meters per second, 25 degrees north of east, and the airplane's velocity is 100 meters per second, 20 degrees west of north, and we want to find the resultant. So the way we're going to treat this is just like we did before. We're going to break up our x and y components with the velocity, so we can draw one for the wind, we can draw one for the airplane. Go ahead and determine the x and y values for both, and then get the total x, total y, and then you can solve for the resultant. So make sure you do each step, you work out each vector, and get each part, and then and determine it. So go ahead and put a pause, and you can go from there. Okay, so we break up vector A into the x and y. So we have a y vector 93.97, and then an x going in the negative 34.2. For our airplane's velocity, vector B, we get an x velocity of 13.59 and a y velocity of positive 6.34. We get our totals. Our total x is negative 20.61, and then our total y is 100.31. And then we can write out our resultant velocity, bringing those together, 102.41 meters per second, 78.4 degrees north of west. So that is the resultant vector of the wind. and the airplane's velocity. So this is very similar to what we did with displacement.